Inelastic collision. Inelastic collision. Students, in the inelastic collision here, we are where the restitution ratio will be lying between 0 and 1. In inelastic collision, restitution ratio will lie between 0 and 1. This is the body of mass m1 moving with the speed u1, another body of mass m2 moving with the speed u2. And after collision, this one moves with the speed v1 and this one moves with the speed v2. In this case, students, momentum is always going to conserve according to LCM, according to law of conservation of linear momentum. According to law of conservation of linear momentum, we can say that m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. So m1 of u1 minus v1 is equals to m2 of v2 minus u. m1 of u1 minus v1 is equals to m2 of v2 minus u. m1 of v1 minus v2 is equal to m2 of v2 minus u. So this is one basic important point. Now students, we know the restitution ratio is equal to v2 minus v1 divided by u1 minus u. So v2 minus u1 equal to e into u1 minus u. Right. So from this, v2 value can be taken as v1 into e of u1 minus u2. v1 will be equals to v2 minus u of u1 minus u. Right. v2 minus v1. So minus v1 goes to that side. v2 equal to v1 plus e into u1 minus u2. v1 is equals to v2 minus e of u1 minus u2. Now students, in this case, to find v1, let us say this is equation 1. This is equation 1. To find v1 here, eliminate v2. Put value of v2 in equation 1. So this implies m1 u1 minus m1 v1 is equals to m2 of v2. Students, v2 is like this here. Put this value over here. v1 plus eu1 minus eu2 minus u, like this. Okay. So if you put these values and evaluate only v1 terms here. So m1 v1 plus m2 v2. On this side, students, we have m1 u1 minus m2 u2 plus m1 u1 minus m2 u1 . So other terms are m2 u2 plus e into m2 u2, m1 v1 plus m2 v1. So if we take out v1 as the common factor, it would be m1 plus m. So m1, if we take 1 minus e as common factor, 1 minus e into m1 minus e into u1 plus one plus e into m2 u. So therefore, velocity v1 is equals to m1 minus em2 whole divided by m1 plus m2 into u1 plus 1 plus e into m2 u2 whole divided by m1 plus m. Have understood this equation? Vignesh, other students, Rishan Chaudhary, other students. This is how we can evaluate the value of v1. Yes, Shashank, right. Students, actually, the velocity v1 in our general case is m1 minus m2, general formula. If restitution is not there, m1 minus m2 in plus m1 plus m2 is 1. So 1 plus e into m2 u2 whole divided by m1 plus m2. So in this case, students, e equals to 1. Like this. Can we obtain this one? Put e equal to 1 here. Put small e equal to 1 here. Put small e is equals to 1 here. If we put e equal to 1 in this one, Vignesh, y means we'll get the result for the elastic collision. No? This is for elastic collision. Vignesh, okay, understood, ma? E equal to 1 here. We'll get this result. M1 minus M2 divided by 2M2. So E equal to 1. 1 plus 1 will be 2. M2 U2 divided by M1. Now, let us, can I write this? Students, have you copied this part? Okay, 1 minute. Okay, please, I will wait for 1 minute. Please check it down quickly. Please take it down quickly. Right, complete. Now, students, we need to find V2 value. What we have to do? Students, we are going to find the value of V2. Students, to find the value of V2, we have to eliminate V1. To find V2, eliminate V2, put the value of V2 in equation 1. Yes, ma'am. Okay. Yes, eliminate V1. Okay, now eliminate put the value of V2 in equation 1. Eliminate V1 value. Yes, yes. So use this result. Now in this case, M1 into U1 minus V1 value minus V2 plus E into V2 minus V2. So this implies here M1 U1 minus M1 V2 plus M1 into E into V1 minus M1 into E into V2 equals to M2 V2 minus M2 V2. So here students we can see 1 plus E into M2 U2 plus M2 minus EM1 is equals to V1 plus V2 V2 into M1 plus M. So therefore velocity V2 of the body is equals to 1 plus E into M1 U1 plus M2 minus EM1 into U2 whole divided by M1 plus M2 here and here also. Now, is this okay? Students, please see the continuation. Here in this term and in this term, we can take out U1 as term 1 plus E into M1 U. So here M1 right. Am I understood by this part? Now please see this calculation. 2 minutes. Okay. If I put E equals to 1, students, in this case, if I put E equal to 1, will we get this result of V2 is equals to 2 M1 U1 divided by M1 plus M2. Like this. Now students, have you taken this part? Okay, please complete mark Vignesh. After finding the values of V1 and V2, If the second body is at rest, students, if V2 is equal to 0, then the value of V1 is what? M1 minus EM2 into U1 whole divided by M1 plus M. And second body velocity, if second body is at rest, so U2 is equal to 0. If U2 is equal to 0, students, if I put U2 equal to 0, this will vanish. So that means we have only this part, 1 plus E into M1 U1 whole divided by M1 plus M. In a special case, students, if the two masses are same, if the two bodies are identical, students, if the two bodies are identical, this means that M1 is equals to M2 is equal to small. Both the masses, materials will be same, size will be same. Material same means density will be constant. Size same means radius volume will be constant. So density times volume mass will be also constant. So V1 will be equals to M minus EM whole divided by M plus M into U1. That is 1 minus E into U divided by. So or else go for the next step. 1 minus E into MU whole divided by 2M. MN cancel. So 1 minus E whole divided into U by 2. 1 minus small e into U by 2. Similarly, go for the second velocity. Therefore, 1 plus E into M into U1 whole divided by M plus M. That is equals to 1 plus E into M U1 whole divided by 2. These two gets cancelled. 1 plus E into U1 by 2. 1 plus E into U1 by 2. Now students, let us find the ratio of the two velocities, the ratio of the speeds of the two bodies, final velocity. V1 upon V. The ratio of the final velocities V1 and V2. V1 to V2. So therefore students, V1 upon V2 can be taken as 1 minus E into U by 2. 1 plus E into U by 2. So these two will cancel out. So we have 1 minus small e divided by 1 plus small. Very, very, very important. So this is a very, very, very important point. 1 minus E divided by 1 plus. Very, very important. Suppose in this case, students, in this case, if restitution ratio equals to 0.5, then the value of V1 upon V2 is how much? Please tell that value. Yeah, 0.5 by 1.5. Yes, 1 is to. Students, this would be equals to 1 by 0.5 by 1.5, that is 1 is to. Is that okay? Harsha, Sandeep, okay? Shashank, are you there? Yes, right. Right. Can I write this part, students? Can I clear this point? So now, students, in the same point here, we have to find the loss in energy. Suppose take for example, the first body m1, second body m2. This is moving with velocity u2. This is with u1. The first body moving with v1. The second body moving with the speed v. In the elastic collision, kinetic energy final will be less than kinetic energy initial. Loss of energy. You know that loss of energy takes place. And this loss of energy will be either in the form of heat energy or light energy or the form of sound energy. Might remember this one. This loss may be in the form of heat energy, light energy or the sound energy. So now we need to find the lossing energy. Students, we need to find the lossing energy. So lossing energy is equal to delta K. That is kinetic energy initial minus kinetic energy final. So delta K initial kinetic energy is half m1 u1 square plus half m2 u2 square minus half m1 v1 square plus half m2 v2 square, like this. Students, we know the values of v1 and v2 very well. If we put the values of v1 v2 in this above equation and further calculation, students, know the values of v1 and v2. Put v1 and v2 values in this equation, like this. On solving, students, if you go on substituting these cases, on further solving, here, please solve here, on solving, we get that delta K is equals to half m1 m2 divided by m1 plus m2 into u1 minus u2 whole square into 1 minus e square. This is a very, very important point. Students, lossing energy. We know the big values of v1 and v2. Put those values of v1 and v2 here and here and proceed the calculation. You get delta K as like this. Half m1 m2 divided by m1 plus m2 into u1 minus u2 whole square 1 minus e square. Okay, ma, understood, ma? Suppose if they ask fraction loss in energy, what is the fraction loss in energy? Fraction loss in kinetic energy is given by delta K divided by K initial. What is delta K? Here you have this part. Half m1 m2 divided by m1 plus m2 into u1 minus u2 whole square into 1 minus e square. This is delta K whole divided by K initial. That would be equals to half m1 u1 square plus half m2 u2 square into 100. Sorry, only percentage, the fraction number. So fraction means you can consider only this part. For percentage change in energy, you have to multiply with the 100. So if they ask a percentage loss in K, then delta K by K into 100 we have to consider. You understood, ma? So this formula is very, very important. Loss in energy delta K is very important. So delta K divided by K initial, if you do this calculation, we get a result of this kind. So if they ask a percentage, then we should go in this way. Now let us do some simple question here. A body of mass m collides with the velocity u, collides with the velocity u. Another body of mass m at rest. If the percentage loss of energy is 20 percentage equal to 0.5, find the ratio of the masses. Find the ratio of the masses. We need to find m1 upon m2 is how? A body of mass m1 collides with the velocity u to another body of mass m2 at rest. If the percentage loss of energy is 20%, students, they set percentage loss. You see here, 20 percentage is the loss in energy, the delta k1. So this is delta k. So if they ask percentage loss, we have to multiply with the 100. So this one. So here is a situation, students. Here is a situation where in the problem, in this problem here, second body is at rest. U2 is equal to 0. U2 is equal to 0. U2 is equal to 0. If the second body U2 is equal to 0, U2 is equal to 0. Let us see what we can see. So this value delta k by k into 100 is given as 20%. So 20 is equals to 1 by 2 m1 m2 whole divided by m1 plus m2 u1 minus 0 whole square 1 minus 1 by 2 whole square whole divided by 1 by 2 into m1 into u1 square plus 1 by 2 into m2 into 0 square. And this would be into 100. This is into 100. Okay. Now students, please see the calculations here. Okay. Can you tell the value? Find the value of m1. Yes. 1 minute. Okay. Make it soon, students. Make it soon quickly. calculated, 1:4, 2:3. Okay, let us see my calculation. Let us see the calculation on here. Okay. Okay, so this is equals to 20/100 is equals to m1 m2 divided by m1 plus m2 into 1/2 into u1 square. This term is cancelled. So whole divided by 1/2 m1 u1 square. So half m1 u1 square, half m1 u1 square gets cancelled. So here 1 minus, this is there, 1 minus 1/2, 1 minus 1/4. So 1/5 is equals to m2 divided by m1 plus m2 into 3/4. So multiply with 4. 4m1 plus 4m2 is equal to 15m. So therefore 4m1 is equals to 11m2. So therefore m1/m2 will be equals to 11:4. Yes. Is that okay? Students, is the question clear to everyone? Right. Students, can I write this part one? Yes, sir. Now, another important students, another simple question. We already learned in the previous class. This is a circular ring like this. A body of mass m moving with a velocity and strikes another body of mass at rest. A body of mass m moving with a velocity v, and it strikes another mass which is at the diametrically opposite end. This is of radius r. The time interval between, students, calculate the time interval between the first collision and the second collision. Between first collision and the second collision. First collision and the second collision. Similarly, between the second collision and the third collision. If you know the times for first, second, and third, very easily you can calculate. Okay. So for the first collision to occur, students, for the first collision to occur, this body of mass m has to travel what distance? This body of mass m has to travel what distance for the collision to take place? It has to travel half the circumference. Half the circumference. So for the first collision to take place, for the first collision, time t1 is equals to distance divided by the velocity, relative velocity. Yes, ma'am, very good. Distance divided by the relative velocity of approach. Students, relative velocity of approach. V relative approach is equals to u1 minus u. As u1 is v, this is 0, this would be v here. So therefore, s is equals to pi r divided by. Am understood, ma'am? Can you see this top of sentence, ma'am? Relative velocity of approach is equals to, this is a first body is moving with a velocity v1. Second body is is at rest. Second body is at rest. This travels this much distance and strikes. And this is half the circumference. If I go, yes, that is half the part. If I go for the complete length for the second collision to take place, it would have traveled for the second collision means full circumference. What is the full circumference of a circle of radius r? 2 pi r. It will be 2 pi small r. Yes. Now students, for the second collision to occur, time t2 will be equal to distance divided by relative velocity of approach. So restitution ratio is nothing but v2 minus v1 divided by u1 minus u. Okay. So v relative approach to the v relative operation. Like this. So V relative separation is equals to E into V relative approach. Like this. So students, after collision, the two bodies will be traveling with a velocity, relative velocity of v2 minus v1 is relative velocity of approach is equals to relative velocity of separation. It is separation by approach. So v relative of separation is equals to E into relative velocity of approach. That is equals to E into. What is the approach velocity here? V. So therefore, we can say v2 minus v1 is equals to E into. So that means this is 2 pi r for circumference one. Students, for the second collision to occur, it would be here. Again, it has to travel one distance, one circular path. Is it or not? Now, please answer. For the second collision to take place, it has to travel 2 pi r. And this is nothing but v2 minus v1, that is 2 pi r divided by E into velocity. Students, in the last week also we derived this one. And we said E equal to 1 here. That is 2 pi r by small. Is it or not? 2 pi r by v we got it. 2 pi r by v got it. But here restitution ratio is included as v2 minus v1 is here. Now, similarly, students, for the third collision to take place, T3 equals to again distance divided by relative velocity. Okay. So again, in the second part, if you say in the same way, so v2 dash minus v1 dash is equals to small e into v2 minus v1. So e into ev, that is equals to e square v1. So therefore, this would be equals to, again for the third collision to take place, we go with v2 dash minus v1 dash. Again the velocities will exchange. Sorry, the two velocities will change. v2 dash minus v1 dash can be taken as e square v. So therefore, it is 2 pi small r divided by e square times. You understood now? For the first collision to take place, this has to travel like this. Half the circumference divided by velocity v. For the second collision to take place, one circumference should be completed 2 pi r by relative velocity. By the time the first collision has happened, both the bodies are brought into motion, and the relative speed between them will be equals to v2 minus v1 from the above expression ev. So ev. So for the third collision to occur, already the two bodies are in motion. Relatively they are moving means again we have to find the relative velocity difference for the third collision to take place. If I say the circumference is 2 pi r again, V2 dash minus V1 dash. As said in the above, it is E V2 minus V1, that is E into EV is square. So 2 pi r divided by V2 dash minus V1 dash, that is 2 pi r by E square. Have you understood this model? Right. Okay. Shall I wait for some time or can I write this one? Okay. Fitness is studying in Mongol food rain. It is also raining very, everywhere it is raining. Yes, Setu. Yes. Tenali also. Tenali, Mongol, yes. Okay, okay, okay. Okay, right. Bharat is telling that since yesterday no powers are only my charge level is 9%, what to do? Please keep your device in the battery saver. Bharat, keep the device in the battery saver. At least to the end you can find that. Okay, students. Now we are going to discuss perfectly inelastic. Perfectly inelastic position. Okay. Okay, please, Raghunandan Reddy, other students, please answer. In perfectly inelastic position. In perfectly inelastic position. The body of mass M1 moving with the speed U1 and this is of mass M2 moving with speed U2. After colliding, both the bodies M1 plus M2 move with common speed Vs. Move with the common velocity Vs. M1 with U1, M2 with U2. The total mass M1 plus M2 is moving with a common velocity. So here in inelastic collision, both the bodies move together. The bodies stick together. The bodies stick together and move with common velocity. Move with common velocity. Both the bodies stick together and move with the common velocity. Move with common velocity. Bodies stick together and move with the common velocity. That is a perfectly inelastic collision. And in this, students, in elastic collision, perfect inelastic collision, the restitution ratio will be equal to 0. According to law of conservation of momentum, according to law of conservation of linear momentum, total momentum initial M1 U1 plus M2 U2 is equals to M1 V common plus M2 V common. So M1 U1 plus M2 U2 is equals to m1 plus m2 into v common. Therefore, the common velocity is Vc is equals to m1 u1 plus m2 u2 whole divided by m1 plus m2. Srinivas, if your charging levels are very low on your device, please switch on. Please switch on the mode to battery saver mode. Switch on to the battery saver mode. At least that would be useful, so that you do not get discharged, drained out, and retain the power till the end of the class by 12:45. So common velocity will be like this. 2 will not work. Okay. So here, students, if the second body is at rest, in this scenario, case 1 mark. Second body is at rest. Second body at rest means, students, what it means here, u2 is equal to 0. Then v common will be equals to m1 u1 plus m2 into 0 whole divided by m1 plus m. So therefore, v common in this case is m1 u1 whole divided by m1 plus m. V common is equals to m1 u1 whole divided by m1 plus m. On the other case, students, case 2. If both move in opposite direction, if both the bodies move in opposite direction, that is, the first body is moving with the speed u1, second body is moving with the speed u2 in opposite direction. Then V common together, if the system is also moving in the same direction like this, so then V common will be equals to m1 u1 minus m2 u2 whole divided by the total mass m1 plus m. Total mass m1 plus m. Okay. Considering that this momentum is more, first body momentum is more. Why? Because after collision, both the bodies are moving in what direction? Is it the direction of the first body or in the direction of second body? After collision. Though initially they are moving in opposite directions, after collision, both the bodies are moving in the direction of motion of the first body. So first body means whose momentum will be more? That will happen only if momentum of the first body is more. Yes, first body is more. So m1 u1 minus m2. Suppose that if the system moves towards left, then what we have to write for v common? Yes, first we have to write m2 u2 minus m1 u1. So numerator will start with m2 u2 minus m1 u1 divided by m1. Okay, students, in this case, loss in energy. Students, in this case, loss in energy delta K will be equals to of m1 m2 divided by m1 plus m2 into u1 plus u2 whole square into 1 minus E will be 0 now, like this. Am I understood, ma? You know the general formula. You know the general formula we derived. So here we mentioned here u1 plus u, u1 plus u, u1 plus u2 whole. Students, why I kept small e as 0? Because for perfect inelastic collision, small e is equal to 0. So delta K is half m1 m2 by total mass m1 plus m2. What is the difference now? If they move in the same direction, students, if the two bodies move in the same direction, here the sign will be what? Minus. Both the bodies move in the same direction, we will be getting minus sign here. they are moving in opposite direction, in this case we'll be getting plus sign. Yes. Yes. So do remember this point. So this is a very important point. You can derive on your own later. Let us see case 3. Let us see the case 3. In the case 3, the first body of mass m1 is moving with the velocity u1. And second body of mass m moving with the speed u2. Right? Both strike together and with the common velocity in this direction. This is the direction of first body along x-axis. And this is the direction of motion along y-axis like this. We need to find this common velocity. So in this case, students, V common can be taken as P1 I cap plus P2 j cap whole divided by M1 plus M. You understood now? But here, V common in this case is equals to, as the two vectors are perpendicular, this vector is P1 bar and this vector is P2 bar. This vector in our direction is P2 bar. And the angle between them is at right angles. So P1 square plus P2 square plus 2 P1, P2 and this is cos 9. This will vanish. Whole divided by M1 plus M. So therefore, V common in this case will be equals to root of P1 square plus P2 square whole divided by M1 plus M. So also students, this can be mentioned as root of M1 U1 whole square plus M2 U2 whole square whole divided by total mass M1 plus M. Suppose in a special case, if both the momentum are same, P1 equal to P2 equals to, then what is V common velocity? That would be P square plus P square whole divided by M plus M. Momentum same is masses are also same. Let us suppose. In that case, it can be taken as root 2P divided by 2M. So root 2 into MU divided by 2M. MM gets cancelled. So this velocity will be U by root. You understood this third case? Now, how the third case is different from first and second? How the third case is different from first and second? The motion of the two bodies are in what direction? Perpendicular direction. Perpendicular. Yes. It is something like a two-dimensional equation. Okay, let me tell 4 summary points. Both the bodies moving in the same direction. It is a one-dimensional collision. It is one dimensional, but the second body is at rest. It is also one-dimensional collision, but both the bodies are moving in opposite direction. And here, the two bodies are moving in perpendicular directions in the xy plane. So the common velocity of this combined mass M1 plus M2 will be given in this way. V common equal to like this. In the special cases, if we say that momentums and masses are same. The v common velocity. This one will travel with the velocity u by root. U by root. Okay, understood, ma? Can I make this part? Shashank, other students, please tell me, ma. Shall I wait for 1 minute, point? 1 minute time? Okay. Completed, sir. I need to wait for 1 minute. Okay, I'll wait for 1 minute. Salman Raj, other students, I will wait for 1 minute. Please complete it quickly. Okay, students. So in this case, let us do the simple thing. In the perfectly inelastic condition, we are going to find the loss in energy. We are going to find the loss in energy. This is the first body of mass m1 moving with velocity u1. This is the second body of mass m2 moving with the velocity. So the two bodies fling together, moving the common velocity m1 plus m2. So here, loss in kinetic energy of the system. Loss in kinetic energy of this system is equals to A initial minus A final. A initial is half m1 u1 square plus half m2 m2 square minus half m1 plus m2 into V common square. But students, you know very well, V common is nothing but one more. Delta T. This is delta T. V common is nothing but half m1 u1 square plus half. Okay. Therefore, call as common here m1 u1 square m2 u2 square minus of m1 plus m1 plus m2 to be common. m1 u1 m2 u2 divided by m1 plus m2 whole square. Like this. So this implies that here 1 by 2 m1 u1 square plus m2 u2 square square u2 square plus 2 m1 m2 into u1 u1 u2 all divided by m1 plus m2. You understood? m1 u1 square plus m2 u2 square minus of this part all divided by m1. There is a square term in the denominator. Only one term is there. One term will cancel out. I expanded a plus b whole square in the numerator. Is that okay? So is that okay, Shashank? Other students, please see. Right. Now, this part is nothing much. So 1. Let us take the LCM. So delta K in this case will be is equals to LCM is m1 plus m2. LCM is m1 plus m2. Multiply this part here. Plus m1 m2 into u1 square. I expand this term now. m1 square u1 square. m2 square u2 square minus 2 m1 m2 u1 u2. Epic lengthy derivation, epic term came, but don't worry about this, students. Two terms will cancel out. Two pairs will cancel out. Identify the two pairs which get cancelled out. Identify the two pairs which will get cancelled out. Yeah, right. m1 u1 square will cancel out. Any other thing? m2 u2 square, m2 u2 square will also cancel out. Right, okay. Now tell me, in the remaining three terms, we can take out one thing as common factor. What is that common factor? Witness only m1 or m2 is also there. Yes, m1, m2 can be taken. So delta K will be equals to 1 by 2. m1, m2. u1 square plus u2 square minus 2 u1, u2. All divided by m1 plus m2. Will be equals to m1, m2 divided by total mass m1 plus m2 into u1 minus u2 whole square. Understood? Am you there? बच्चों देखो यहाँ पे a square plus b square minus 2a. You just check this one, you will get that result, right? Okay. Now see, students, here delta K is like this. The two bodies are moving in the same way. U1 is in this direction, U2 is also in this direction. Okay. But I said here, there is a plus sign. Am I understood? If the two bodies move in opposite directions here, so this minus is there initially if they move in the same direction. If you do the same derivation for the opposite motion in the same process, at the end you will be getting plus. You understood? Is that understood? Seven other students? Right. Very good. So this is about one important information on this side. Perfectly inelastic collision. Perfectly inelastic collision. So in this case, students, if I say second body is at rest, have you taken this part? Shall I wait for 1 minute time? Or please make a quick note of it. Please make a quick note of it. Right, Shashank? If okay, 2 will be there in the denominator. Students, Shashank, if u2 is equal to 0, 2 will be there. You missed out 2, na? Perhaps. Yeah, yeah. If the second body is at rest, if second body M2 is at rest, if the second body M2 is at rest, then its velocity u2 would be equal to